Hello students, in my previous videos I have explained in detail about the methods of finding initial feasible solution under transportation problem. Those methods were northwest corner method, which was a direction oriented method, least cost method wherein the importance was given to the cell which is having the least cost, and the next method is Ogle's approximation method, which was also called as penalty method. And in today's video I am going to explain about the methods of finding optimal solution under transportation model. The first method among those are stepping stone method. Before going for understanding stepping stone method, I would like to give an example. In case of module 3 simplex solution, while we were solving problems under two-phase method, we have seen that the whole solution was divided into two phases. In the first phase, we used to obtain initial feasible solution, and the same solution we used to take it as a base for phase 2 for obtaining optimal solution. In the same way, in case of stepping stone method, first we will take the initial feasible solution obtained under any of the three methods. Here any of the three methods in the sense either it may be northwest, least cost or Ogle's method. I am telling any of the method because it depends upon the question. And next, here we calculate net cost change that can be obtained by introducing any of the unoccupied cells into the solution. This net cost change you're going to understand in detail when we take an example and solve the problem. Here in case of stepping stone method, we even consider the unoccupied cells in the solution. That means in the previous methods we used to not consider the unoccupied cells, but in stepping stone method we do even consider the unoccupied cells into the solution. Let us see an example. And before going for the example, let us see steps for solving stepping stone method. So step 1, find an initial basic feasible solution using any one of the three methods. So we have to find initial basic feasible solution, and later we need to check for degeneracy in the obtained solution. What is degeneracy? If degeneracy is present in the problem, we cannot find the optimal solution. So that is the reason we have to check for degeneracy. If the problem is not degenerate, then we can easily find out the optimal solution. Next, let us see an example. Find solution using Ogle's approximation method. Also find optimal solution using stepping stone method. So as I have told earlier, it all depends upon the question, the method what we are using. So in this example, they have asked us to solve the problem first based on Ogle's method and then stepping stone method. So problem goes this way. There are 4 destinations and 3 sources. Demand of 5, 8, 7, 14 units. Supply 7, 9, 18 units. So whether this given table or a problem is a balanced or unbalanced. So this is a balanced transportation problem because supply is 34 units and even demand requirement is also 34 units. So coming to the solution, as I have told earlier, supply constraints are 3 and demand constraints 4. Now, as I have told earlier, first we are going to solve the given problem on the basis of Ogle's method. Why we are solving on the basis of Ogle's method? Because in our example, so we have been asked us to first find solution using Ogle's method and then go for stepping stone method. So now first we need to solve the problem based on Ogle's approximation method. I have explained in detail earlier. Now let us go for the solution. So what is the first step that is used in solving Ogle's method? First we need to identify the row penalty as well as column penalty. This is the first step. How do we identify the penalty? First we need to identify the least cost and then identify the next least cost. So difference between the two is called as penalty. Now let us see the penalty for the first row, that is S1, which is the least cost in S1, 10. Next least cost is 19. So 10 minus 19 is 9. Coming to the next row, what is the least cost? 30. Next least cost is 40. So difference 10 is the penalty for second row. Coming to the third row, least cost is 8. Next least cost is 20. So penalty is 12. Now we have identified penalty for the 3 rows. Come back to the column penalty. What is the first column? D1, which is the least cost, 19. Next least cost is 40. So difference 40 minus 19, 21. Least cost 8 in case of D2. Next least cost is 30. 30 minus 8, 22. And in case of D3, least cost 40. Next least cost is 50. What is the difference? 10. And in case of D4, least cost is 10. Next least cost is 20. The difference is 10. Now we have identified both row penalty as well as column penalty. What is the next step that we follow in case of Ogle's method? After identifying the penalty, we have to identify the highest penalty. So here, when we observe row penalty, they are 9, 10, 12. And when we observe column penalty, they are 21, 22, 10, 10. So among these penalties, which is the highest? So 22 is the highest penalty. So we have to go for allocating D2. Yes, because it has this column has the highest penalty. Now among D2, to which cell we have to allocate? We have to allocate to this cell because it is the least cost. Now corresponding to 8, what is supply? 18 units, demand is 8 units. So maximum how many units I can allocate? I can allocate 8 units. So when I allocate 8 units, so demand of 8 will become 0. See table 2, I have allocated 8 units. So 8 units of demand became 0 and 18 units of supply became 10 units of supply. Now as the demand became 0, the whole column is crossed off. That means the whole destination is crossed off because there is no demand requirement from that destination. And repeat the similar procedure. Now again find out the penalty. Come to the first row, least cost 10. Next least cost is 19. So penalty 19 minus 10, 9. S2, least cost 40. Next least cost 60. Penalty is 20. Next S3, least cost 20. Next least cost 40. So 40 minus 20, 20. Now come to column penalty. So in case of D1, lowest cost 19, next lowest cost 40. So 40 minus 19, 21. In case of D3, least cost 40, next least cost 50. What is the difference? 10. 50 minus 40, 10. In case of destination 4, least cost is 10, next least cost is 20. So what is the penalty? 20 minus 10, 10. Now we have identified the penalties. Find out the highest penalty. So highest penalty is here in case of D1. So we have to go for allocating the units for D1 column. Yes, so we have to allocate for D1 column. Compare the demand units. Demand is 5 and here we have 3 rows, 19, 70, 40. To which cell we have to allocate? We have to allocate to such cell which is having the lowest cost. So here 19 is the lowest cost, so we need to allocate to this cell. Now compare the supply. Supply is 7 units, demand is 5 units. So maximum how many units I can allocate? I can allocate 5 units. So here demand will become 0 and supply will become 2. See here, demand has become 0, supply has become 2 because we have allocated 5 units here. This column already we got earlier, and now as demand has become 0, we cannot allocate more, so even this column is crossed off. Now again continue the procedure. Find out the row penalty for S1. It is 50, which is the least cost, 10, next least 50. So 50 minus 10, 40. 40 least cost, next least cost 60. 60 minus 40, 20. Least 20, next least 70. Difference is 50. Now come back to column penalty. These two columns we won't find any penalty because they are crossed off. Coming back to the D3, least cost is 40, next least is 50, so difference is 10. D4, least is 10, next least 20, so 20 minus 10, 10. So which is the highest penalty? 50 is the highest penalty. So we need to allocate to this row. So this row has two cells, one is 70 rupees and one is 20 rupees. Now we have to allocate to such cell which is having the least cost. So 20 is the least. Now compare the supply 10, demand 14. So how many units we can allocate? Maximum we can allocate 10 units. So when we allocate 10 units here, supply will be 0. See here, you can observe here, when 10 units are allocated, supply becomes 0, and from 14 units of demand, when 10 units are allocated, 4 units are remaining. Now as the supply became 0, the whole column will be crossed off because we cannot supply anymore. Now two columns are remaining, D3, D4, destination 3, destination 4. So come back to S1, find out the penalty, 10, 50. So 50 minus 10, 40, 40, 60. So 60 minus 40, 20. And in case of D3, 50, 40. Penalty is 10, 10, 60. Penalty is 50. So which is the highest penalty? 50. And corresponding to 50, so D4 column we need to allocate now. We have to allocate to this cell which is having 10 rupees. This is the least cost. Now compare the demand. Demand is 4 units, supply is 2 units. How many units I can allocate? 2 units. Now supply becomes 0 and demand becomes 2. You can observe here, supply has become 0 and demand has become 2. Now as the supply has become 0, we cannot allocate more to this row. So this row is crossed off, and S3 is earlier crossed off, D1 earlier crossed off, and D2 earlier crossed off. Now find out the row penalty for S2. So 40, 60. 40 minus 60 minus 40, 20 is the penalty. For D3, there is no another number to compare. So whatever is remaining, we are going to take that as a penalty. So 40, 60. Which has the highest penalty? 60. So to this row we have to allocate now. Only this cell is remaining. So to this cell we are going to allocate supply of 9 units, demand of 2 units. So maximum I can allocate 2 units. So here you can observe 2 units are allocated, for which demand becomes 0 and supply becomes 7. Supply in earlier case was 9. After allocating 2 units, it became 7. Now demand has become 0, so even D4 is crossed off. So totally D1, D2, D4, S1 and S3 are crossed off. Now what is remaining? Only S2. So 40 penalty, and in case of D3, 40 penalty is remaining. So compare the supply 7 units, demand is also 7 units. So we can allocate 7 units here. So demand becomes 0 and supply also becomes 0. So by this we have completed allocating. So this is the final initial solution that we get by solving the transportation problem under Vogel's approximation method. So these are all the penalties that we have seen in the slides till now, and these are all the allocations that we have made. 1 2 3 4 5 6. So totally we have made allocations for 6 cells. And now, what was the first step in case of stepping stone method? We need to find out the initial feasible solution and check for degeneracy. So as per this slide, we have found out the initial feasible solution. Now we have to check for degeneracy. What is degeneracy? If the problem is said to be degenerate, we cannot find an optimal solution. So first we need to check for degeneracy. So what is the formula to check for degeneracy? That is m plus n minus 1. M plus n minus 1. So here m in the sense number of rows, n in the sense number of columns. How many number of rows are there? 1, 2, 3. So m is equal to 3. You can observe here. And number of columns 1 2 3 4. So n is equals to 4. So m is 3, n is 4. So 3 plus 4 is 7 minus 1. So it will become 6. So this m plus n minus 1 value must be equal to the number of allocations made to the cells. So what is the number of allocations? 1 2 3 4 5 6. So number of cells allocated is 6, and m plus n minus 1 is also 6. So when these both values are equal, that problem is called as non-degenerate problem. That means we can obtain optimal solution from that problem. So this is in detail about the first step of stepping stone method. So as per the given question, we need to find out the initial solution. Either it may be using northwest corner method, least cost method, or Vogel's approximation method. So in this example, we have solved initial solution using Vogel's approximation method, and then we have to check for degeneracy. What is the formula? So number of allocations made must be equal to the m plus n minus 1. So m is number of rows, n is number of columns. So if both the values are equal, then that solution is non-degenerate and we can find optimal solution for that problem. So in my next video, I am going to continue with step 2 of solving stepping stone method. Thank you.